Imagine a mind trapped in a body that betrays it more each day, yet somehow finds a way to illuminate the darkest corners of the universe. Picture a young man given 2 years to live, who instead discovers that even black holes, those cosmic graveyards where light itself cannot escape, actually glow with their own gentle radiance. This is the story of how personal darkness became the source of the most brilliant light in modern science. Hello, and welcome to the Sleepy Astronomer. Tonight, we're drifting into the extraordinary life of Stephen Hawking, a journey that takes us from a devastating medical diagnosis to the revelation that darkness itself is luminous. We'll explore how a mind facing its own mortality unlocked secrets about the universe that no one had ever imagined, discovering light in the very places where light was thought impossible. If you're settling in for the first time, welcome to this gentle exploration of wonder and discovery. And if you've journeyed with me before through the quiet mysteries of the cosmos, it's wonderful to have you back among the stars. Whether you're tucked into bed, curled up in your favourite chair, or perhaps lying back where you can see the night sky through a window, I'm glad you're here tonight. Our journey begins on January 8th, 1942, when Stephen William Hawking was born in Oxford, on the very same day that Galileo had died exactly 300 years before. It's as if the universe had planned a cosmic handoff, one brilliant mind departing as another arrived to continue illuminating the darkness. But this new light would emerge in the most unexpected way, through struggles that would have extinguished most flames, yet somehow made his burn brighter. There's something profoundly beautiful about the central paradox of Hawking's life. Here was a man who studied the ultimate darkness, black holes, those regions of space-time so dense that not even light can escape their gravitational embrace. And yet, through his mathematics, he discovered that these cosmic prisons actually glow. They emit their own gentle radiation, a soft whisper of light that emerges from the very edge of nothingness itself. This discovery would become known as Hawking radiation, and it represents one of the most elegant insights in all of physics. But perhaps the most remarkable thing about it is how perfectly it mirrors the man who found it. Stephen Hawking himself was trapped, his brilliant mind increasingly imprisoned by a body that grew weaker and more silent with each passing year. Yet from that personal darkness emerged a light so bright it illuminated the entire universe for millions of people. Ancient wisdom, traditions have long spoken of light emerging from darkness, of lotus flowers blooming in muddy waters, of stars being born in the cold depths of space. Stephen Hawking's life embodies this ancient truth in the most literal way imaginable. His physical limitations became the very source of his transcendence. His silence gave him a voice that spoke to the world. His confrontation with death led him to reveal the hidden life of the cosmos. Tonight, we'll trace this transformation from darkness to radiant light. We'll see how a terminal diagnosis at age 21 became the beginning rather than the end of his story. How losing his natural voice allowed him to find a universal language that millions could understand. How studying the most extreme gravitational prisons in the universe taught us about the fundamental nature of reality itself. This is not just the story of one remarkable man, though Stephen Hawking was certainly that. It's the story of how limitation can become liberation, how constraint can spark creativity, and how facing our deepest fears can lead to our greatest discoveries. It's about the mysterious alchemy by which personal struggle transmutes into universal wisdom. So, settle in comfortably tonight, and let's explore together how darkness became light, how silence became song, and how one man's journey into the abyss revealed that even the darkest places in the universe are quietly, beautifully, eternally glowing. Take a deep breath, and let's begin our gentle drift into the extraordinary life of the man who taught us that black holes shine. Picture London in January 1942. The city sleeps fitfully under blackout curtains, while searchlights sweep the sky like fingers, feeling for death in the darkness above. In the distance, you can hear the low rumble of aircraft engines. Friend or foe, it's impossible to tell in those first anxious moments. The smell of coal smoke and worry hangs in the cold air, mixing with something else. The metallic scent of a world balanced on the knife's edge between civilization and chaos. It's into this world of shadows and uncertainty that Stephen William Hawking draws his first breath on January 8th in the ancient spires of Oxford. Outside his window, gargoyles carved centuries ago seem to watch over a city transformed into something from a nightmare. Yet inside this modest house, wrapped in blankets against the winter cold, a baby's cry pierces the darkness, a sound that somehow carries hope, as if the universe itself is announcing that light will find a way to shine, even in humanity's darkest hour. His mother, Isabel, holds him close as sirens wail in the distance. She's an unusual woman for her time, university educated when most women were expected to be satisfied with marriage and motherhood. Her mind is sharp as winter air, filled with questions about literature and philosophy that most people find unsettling. She traces her finger along her newborn son's palm, perhaps wondering what secrets those tiny hands will one day unlock. The irony is almost too perfect. Here is a child who will spend his life reaching toward the stars, born during a time when looking up at the night sky meant scanning for bombers. Frank Hawking, Stephen's father, peers at his son through wire-rimmed spectacles, the same intense gaze he uses to examine slides under his microscope. He's a man who finds beauty in the microscopic world of tropical diseases, spending his days hunting malaria parasites through blood samples, with the patience of a monk illuminating manuscripts. There's something quietly heroic about Frank's work, fighting invisible enemies that claim millions of lives, using nothing but careful observation and scientific method. He doesn't know it yet, but his son will inherit this same patient curiosity, this ability to find patterns in chaos, though Stephen will turn his attention not to the smallest scales of life, but to the grandest. The timing of Stephen's birth carries an almost mystical significance. January 8th, 1942, exactly 300 years to the day after Galileo Galilei died in his villa in Arcetri, Italy. Galileo, the man who first turned a crude telescope toward the moon, and saw mountains where church doctrine insisted on perfect spheres, who watched Jupiter's moons dance their orbital ballet and realized that not everything in the universe revolved around Earth, who spent his final years under house arrest, his eyes failing, but his mind still burning with the fire of discovery, whispering truths that made the powerful tremble. 3 centuries later, almost to the hour, another soul arrives who will carry that same flame. It's as if the universe has a sense of poetry, passing the torch from one illuminator of darkness to another. But this new light will shine in ways Galileo could never have imagined, revealing that even black holes, those cosmic prisons where light itself cannot escape, secretly glow with their own gentle radiance. If you had encountered young Stephen in those early years, wandering the rooms of their house in St. Albans, where the family moved when he was 8, you might have mistaken him for any other curious child. Picture him on his hands and knees, surrounded by the dismantled remains of an alarm clock, tiny gears and springs scattered across the carpet like the fragments of some mechanical constellation. His mother finds him there, lost in concentration so deep he doesn't hear her calling his name. The clock will never work again. Stephen has an uncanny ability to take things apart, but putting them back together is another matter entirely. His teachers at St. Albans School despair over his handwriting. It flows across the page like a river that's lost its way, letters tumbling into each other in a cascade of illegible curves. His thoughts move too fast for his hand to follow, one instructor observes, not realizing how prophetic those words would prove. Decades later, when Stephen's hands could no longer hold a pen at all, his mind would soar to heights no one had ever reached, unencumbered by the physical limitations of flesh and bone. The other children call him Einstein, though whether it's meant as praise or gentle mockery, even they aren't entirely sure. Einstein himself had been a notoriously average student after all. Stephen seems perfectly content to drift along in the middle of his class, turning in work that's barely adequate while his mind wanders to territories his teachers can't even imagine. During mathematics lessons, while other students laboriously work through equations step by step, Stephen stares out the window at clouds drifting across the Hertfordshire sky, somehow arriving at the correct answers through pure intuition. What's happening, though no one realizes it at the time, is that Stephen is teaching himself to think in ways that will later prove essential. While his classmates memorize formulas and regurgitate facts, he's learning to see patterns, to feel the underlying logic that connects seemingly unrelated concepts. It's as if his mind is a radio receiver, naturally tuned to frequencies others can't detect, picking up signals from the deep structure of reality itself. The 1950s drift by like a dream half remembered. Britain is rebuilding itself from the ashes of war, but underneath the optimism lurks a new kind of anxiety. The same scientific knowledge that brought victory in 1945 now threatens to end human civilization entirely. Atomic bombs cast shadows over every playground, every classroom, every dinner table conversation. Children practice diving under desks, as if a few inches of wood could shield them from nuclear fire. Science has become both saviour and potential destroyer, and young Stephen is growing up at the precise moment when humanity must decide which it will choose. Perhaps it's this backdrop of existential uncertainty that draws Stephen toward the abstract beauty of mathematics and physics. While the adult world wrestles with the terrible power of split atoms, he finds refuge in the elegant certainties of mathematical truth. Here, in the realm of pure thought, there are no ambiguities, no moral complexities, only the crystalline logic of equations that describe the fundamental workings of reality. His father Frank quietly hopes Stephen might follow him into medicine. There's something almost heartbreaking about this paternal wish, given what the future holds. Frank spends his days healing, trying to save lives ravaged by tropical diseases, using careful scientific observation to fight invisible enemies. He can't know that Stephen will need to understand the workings of the human body for reasons far more personal and painful than anyone could imagine. But Stephen is drawn elsewhere. He finds himself staying up late into the night, not studying for exams but reading popular books about cosmology and quantum mechanics. Picture him by lamplight, 13 years old, his eyes growing wide as he encounters concepts that would challenge most university students. The expanding universe, particles that seem to exist in multiple places simultaneously, the strange marriage of matter and energy described by Einstein's famous equation. To most teenagers, this would be incomprehensible gibberish. To Stephen, it's poetry written in the language of mathematics. When the time comes to choose a university, Stephen opts for Oxford, partly because it's his father's alma mater, but more importantly, because Cambridge requires advanced mathematics, which St Albans School doesn't offer. This seemingly arbitrary decision will prove to be one of those strange pivots upon which entire destinies turn. At Cambridge, Stephen might have been just another brilliant mathematics student among many. At Oxford, studying physics, he will encounter the subject not as a collection of formulas to memorize, but as a living, breathing exploration of the deepest mysteries of existence. The Oxford years unfold like a slow waltz. Picture the honey-coloured stone of ancient colleges warming in afternoon sunlight, the soft murmur of conversations drifting across carefully tended lawns, the gentle splash of oars cutting through the Thames on lazy summer afternoons. This is where Stephen discovers rowing, of all things. The future theoretical physicist, who will one day lose the use of his body, finds joy in coordinating the precise physical movements of 8 oarsmen, calling out the rhythm that keeps them moving in perfect synchrony. There's something almost mystical about watching Stephen cox the Oxford rowing team. He sits at the stern of the boat, this slender young man with unruly hair and an impish grin, his voice carrying across the water, as he guides his crew through the ancient ritual of human beings moving together in harmony. The irony is almost too profound to bear. Here is someone who will spend his life exploring the fundamental forces that bind the universe together, learning his first lessons about coordination and balance, while balanced himself on the narrow seat of a racing shell. His approach to physics is equally unconventional. While other students bury themselves in libraries, grinding through problem sets and memorizing equations, Stephen calculates that he's doing perhaps an hour of actual work per day. Yet somehow he stays afloat in one of the most demanding programs in all of higher education. His professors are both impressed and concerned. Here is obvious brilliance, but applied with such casual indifference that they worry about wasted potential. What they don't realize is that Stephen is learning something far more valuable than any curriculum could teach. He's developing an intuitive feel for the underlying patterns that govern physical reality. While others memorize Newton's laws of motion, Stephen absorbs them into his very bones until he can sense how objects will behave almost before calculating their trajectories. It's as if he's becoming fluent in a language that most people can only speak with great effort and careful attention to grammar. The social aspects of Oxford suit him perfectly. He's known for his wit, his ability to deflate pompous arguments with a perfectly timed joke, his talent for making even the most abstract concepts accessible to anyone willing to listen. Picture him at a college party, gesturing with a half-empty glass as he explains the expanding universe to a group of literature students, somehow making the birth of galaxies seem as natural and comprehensible as the changing of the seasons. It's during these years that Stephen first begins to grapple with the deepest questions that will define his career. Late at night in his college room, with the ancient stones of Oxford settling around him like a mother tucking in a child, he stares up at the ceiling and wonders, how did the universe begin? What happened in those first moments after creation? Are there other universes beyond our own? These questions feel less like academic exercises and more like whispered conversations with the cosmos itself. But even as Stephen's mind reaches toward the infinite, his body begins to send the first subtle signals that something is wrong. A stumble on a staircase that doesn't quite make sense. Difficulty buttoning his shirt on mornings when his fingers feel strangely clumsy. These moments pass quickly, explained away as the normal clumsiness of youth, the inevitable result of late nights and too much celebration. By 1962, as Stephen prepares to graduate from Oxford and move on to Cambridge for his doctoral studies, These incidents are becoming harder to ignore. He finds himself dropping things more often, tripping over his own feet in ways that seem increasingly bizarre. Friends begin to notice a subtle change in his speech, a slight slurring that might be attributed to fatigue, or perhaps one too many evenings at the pub. The darkness is gathering, though none of them realize it yet. Like a distant storm building on the horizon, invisible but inevitable, the disease that will reshape Stephen's entire existence is already beginning its slow, methodical advance through his nervous system. Motor neuron disease, a name that sounds clinical and cold but describes something unutterably cruel: the gradual destruction of the very cells that connect mind to body. Thought to action, intention to movement. But Stephen doesn't know this yet. As he sits in his Cambridge College room in the autumn of 1962, surrounded by books on cosmology and general relativity, excited about beginning his research into the deepest mysteries of space-time, he believes he has all the time in the world. He's planning a life of quiet academic research, perhaps teaching, maybe writing the occasional paper that a few dozen specialists will read and appreciate. He has no way of knowing that within a year, everything will change, that he will receive a diagnosis that should end all his dreams, should send him spiraling into despair and defeat, that instead, this devastating news will become the catalyst for the most extraordinary transformation in the history of science, the moment when gathering darkness will begin its slow, miraculous transmutation into radiant light. The universe, it seems, is preparing to teach him its most profound lesson, that even in the deepest darkness, even at the very edge of nothingness itself, there is always, always light. Picture Cambridge in the autumn of 1962, where ancient stones hold centuries of whispered secrets, and the River Cam flows like liquid time beneath willows that have watched generations of brilliant minds come and go. The air carries that particular chill of a British October, sharp enough to make you pull your coat closer, soft enough to remind you that winter is still a promise rather than a threat. It's here, in this city of dreaming spires and endless questions, that Stephen Hawking begins his doctoral studies, unaware that within the space of a single year, his entire universe will collapse and then rebuild itself around the most unexpected foundation: love. He arrives at Trinity Hall like thousands of graduate students before him, carrying a battered suitcase and that peculiar mixture of excitement and terror that comes with stepping into the unknown. His rooms overlook a courtyard where morning mist clings to cobblestones like memories reluctant to fade. The walls are thick enough to muffle the sounds of the modern world, creating a sense of timelessness that suits a young man about to embark on a journey into the deepest mysteries of time itself. Stephen's supervisor is Dennis Sciama, a man whose passion for cosmology burns with the intensity of the stars he studies. Sciama has a gift for making the universe feel intimate and accessible, for transforming equations that describe the birth of galaxies into stories that capture the imagination. Under his guidance, Stephen begins to explore the questions that will define his life's work. How did everything begin? What happens at the moment of cosmic creation? Is there a point where the normal laws of physics simply break down and surrender to something beyond human understanding? These are heady days for cosmology. Einstein's general theory of relativity has opened up vistas of space-time that bend and warp like a cosmic funhouse mirror. The universe itself has been revealed to be expanding, carrying galaxies away from each other like dancers slowly spreading across an infinite ballroom floor. And somewhere in the mathematics lurk these strange entities called black holes, regions where gravity becomes so intense that space and time themselves seem to fold in on themselves like origami made of reality. Stephen throws himself into this work with the kind of intellectual appetite that only comes when someone discovers their true calling. He spends long hours in the library, surrounded by journals filled with equations that look like alien poetry, each symbol a key to understanding forces that operate on scales almost too vast to comprehend. But even as his mind reaches toward the infinite, his body begins to send signals that something is terribly, fundamentally wrong. It starts with small things. A stumble while walking across the courtyard that leaves him embarrassed and confused. Difficulty with his handwriting, which was never good to begin with, but now seems to be deteriorating into something almost illegible. His speech, once crisp and precise, begins to develop a subtle slur that he tells himself is just fatigue from too many late nights studying. The symptoms accumulate like storm clouds gathering on a distant horizon. Stephen finds himself dropping books, struggling to button his shirts, occasionally tripping over nothing at all. His friends begin to notice, though they're too polite to say anything directly. There's something in their eyes when they look at him. Not pity, not yet, but a kind of puzzled concern, as if they're trying to solve a problem they don't fully understand. It's during this period of gathering uncertainty that Stephen receives an invitation that will change everything. A friend from Oxford is having a party, and Stephen, despite his growing physical difficulties, decides to attend. Perhaps he needs the distraction, the familiar comfort of wine and conversation, and the illusion that life is still following its expected trajectory. He has no way of knowing that this party will introduce him to a force more powerful than gravity, more transformative than any cosmic phenomenon he's studying. Her name is Jane Wilde, and when Stephen first sees her across the crowded room, something in the universe shifts. She's 20 years old, studying modern languages at Westfield College in London, with dark hair that catches the lamplight and eyes that seem to hold depths he could spend a lifetime exploring. There's an intelligence in her face that goes beyond mere cleverness, a kind of thoughtful intensity that suggests she's someone who asks the important questions, who doesn't accept easy answers. Jane is discussing literature with a small group when their eyes meet across the room. It's one of those moments that writers have tried to capture for centuries, the sudden recognition that passes between two souls who somehow know they're about to embark on an extraordinary journey together. Not love at first sight, exactly, but something deeper and more mysterious. The quiet acknowledgement that their stories are about to become intertwined in ways neither of them can imagine. Stephen makes his way across the room with careful steps, his body already beginning to betray him in subtle ways that he hopes no one notices. When he speaks to Jane, his voice carries that particular combination of intellectual excitement and social awkwardness that will become so familiar to those who know him. He's discussing cosmology within minutes, gesturing with hands that occasionally seem to move with their own unpredictable rhythm, describing the expanding universe as if it were the most natural thing in the world to contemplate over cocktails. What strikes Jane immediately is not just Stephen's obvious brilliance, but the way he makes complex ideas feel accessible and exciting. He has a gift for finding the human drama in cosmic events, for making the birth of stars feel as intimate and immediate as a conversation between friends. When he talks about black holes, she can almost see them, these invisible monsters lurking in the depth of space, devouring light itself, yet somehow beautiful in their terrible symmetry. They talk for hours that night, long after the other party guests have drifted away. Jane finds herself drawn not just to Stephen's mind, but to something deeper, a kind of gentle courage that seems to shine from within him. There's a vulnerability in his eyes that suggests he's carrying some burden he hasn't yet named, yet he faces the world with humour and curiosity rather than bitterness or fear. Stephen, for his part, is enchanted by Jane's combination of intellectual rigour and emotional depth. She challenges his ideas without being confrontational, asks questions that force him to think about his work from new angles. More importantly, when he's with her, the growing concerns about his physical symptoms seem to fade into the background. In her presence, he feels like himself again, or perhaps like the person he was meant to become. They begin seeing each other regularly, meeting in London when Jane's studies permit, taking long walks along the Thames where Stephen can move at his own increasingly careful pace without drawing attention. Jane notices his difficulties, of course, the occasional stumble, the way he sometimes struggles to find the right words, but she interprets these as quirks rather than symptoms, charming eccentricities that make him more human rather than warning signs of something devastating. It's during one of these London meetings that Stephen first mentions his growing concerns about his health. They're sitting in a quiet pub, autumn light filtering through leaded glass windows, when he tells her about the strange symptoms he's been experiencing. His voice carries the kind of forced casualness that people use when discussing things that terrify them, as if by keeping the tone light, they can somehow minimize the weight of the words. Jane listens with the kind of careful attention that comes naturally to those who understand that sometimes the most important conversations happen in whispers. She doesn't dismiss his concerns or offer empty reassurances. Instead, she simply takes his hand, a gesture that somehow acknowledges both the seriousness of what he's describing and her willingness to face it alongside him. "You should see a doctor," she says quietly, and Stephen nods, knowing she's right, but dreading what he might discover. The irony is almost unbearable. Here he is, dedicating his life to understanding the ultimate mysteries of existence, yet afraid to confront a mystery that's unfolding in his own body. The medical consultations that follow blur together in Stephen's memory like a series of increasingly disturbing dreams. Doctor after doctor, test after test, each one probing deeper into the failing machinery of his nervous system. The British medical system of the early 1960s is not known for its gentleness, and Stephen finds himself subjected to procedures that are both uncomfortable and humiliating, all in service of identifying an enemy that seems determined to remain hidden. It's just before Christmas 1963 when the verdict finally arrives. Stephen is 21 years old, brilliant, in love, with a future that stretches ahead of him like an infinite landscape of possibility. The neurologist's voice is clinically detached as he delivers the diagnosis: amyotrophic lateral sclerosis, also known as motor neuron disease, or Lou Gehrig's disease, after the baseball player who had died of it decades earlier. The news hit Stephen like a physical blow. ALS is a progressive neurodegenerative disease that attacks the motor neurons, the cells that carry signals from the brain to the muscles. As these cells die, the body gradually loses the ability to move, to speak, to swallow, to breathe. The mind remains intact, trapped within a body that slowly shuts down like a machine losing power. There is no cure, no treatment that can significantly slow its progress. The doctor estimates that Stephen has perhaps 2 years to live. Picture that moment, a young man who has spent his life reaching toward infinity, suddenly confronted with the brutal finitude of his own existence. The universe he's been studying, with its billions of years of cosmic evolution, its vast scales of space and time, suddenly contracts to the narrow confines of a medical office where a stranger in a white coat has just pronounced a death sentence. Stephen leaves the hospital in a daze, walking through London streets that seem suddenly foreign and hostile. The world continues around him. People hurry into work, buses belching exhaust, the great wheel of ordinary life turning with complete indifference to his personal catastrophe. He finds himself wondering how the universe can look exactly the same when everything has fundamentally changed. The next few weeks pass in what Stephen will later describe as a kind of waking nightmare. He returns to Cambridge, to his cosmology books and his equations about the birth of the universe, but the work feels hollow now, pointless. What's the value of understanding how everything began if your own story is about to end? He falls into a depression deeper than any he's ever experienced, spending days in bed, avoiding friends, letting his research slide into neglect. It's during this darkest period that Jane becomes the first light piercing through his despair. She doesn't try to minimize the horror of his diagnosis or offer false hope about miraculous cures. Instead, she simply continues to be present, to love him, not despite his illness, but as a complete human being whose worth isn't diminished by the failure of his motor neurons. There's something almost miraculous about her response to his diagnosis. When Stephen finally works up the courage to tell her about the doctor's verdict, expecting her to retreat from what anyone would see as a doomed relationship, Jane's reaction surprises him. She listens carefully, asks thoughtful questions about what the disease will mean for both of them, and then quietly makes it clear that she's not going anywhere. 2 years is 2 years, she says, with a matter-of-factness that somehow makes the impossible seem manageable. That's longer than many people get to be happy. We can be happy. It's Jane who helps Stephen realize that his diagnosis, devastating as it is, doesn't actually change who he is or what he's capable of contributing to the world. His mind, that extraordinary instrument that can contemplate the birth of galaxies, remains unaffected by the disease. The questions that drove him to cosmology in the first place are still there, still demanding answers. If anything, the urgency of limited time makes those questions more pressing rather than less. Gradually, with Jane's gentle encouragement, Stephen begins to emerge from his depression. He returns to his research, but with a new intensity born of the knowledge that time is precious. Every equation he solves, every insight he gains into the nature of space-time, becomes not just an academic exercise, but a race against the biological clock that's now ticking audibly in the background of his consciousness. The engagement happens naturally, almost inevitably, growing out of their shared recognition that love doesn't always come with guarantees about the future. Stephen proposes on a grey January day in 1965, 2 years after his diagnosis, with the awkward sincerity of someone who has learned to value directness over elegant gestures. Jane accepts with the same quiet determination that has characterized her entire approach to their relationship. Not as a martyr, sacrificing herself for a doomed cause, but as a woman who has found someone worth building a life with, however long that life might last. The wedding takes place on July 14th, 1965 at Trinity Hall Chapel in Cambridge. It's a small ceremony, attended by family and close friends, who understand they're witnessing something extraordinary, not just the union of two people who love each other, but the triumph of hope over despair, commitment over uncertainty. Stephen, who by now requires a walking stick for stability, moves carefully down the aisle, but his face carries a lightness that hasn't been there since before his diagnosis. Jane, radiant in her wedding dress, seems to glow with a kind of inner certainty. She's making a choice that many would consider foolhardy, marrying a man with a terminal illness, committing to a future filled with uncertainty and probable heartbreak. But there's wisdom in her choice that goes beyond mere logic. She understands something that the doctors with their statistics and prognoses cannot measure, the power of love to transform even the darkest circumstances into something beautiful. The early months of marriage bring their own challenges and revelations. Stephen's condition continues to deteriorate, but slowly enough that they can adapt to each change as it comes. Jane learns to interpret his increasingly slurred speech, to offer assistance without making him feel helpless, to balance her own needs against the growing demands of caring for someone whose body is gradually failing him. But what emerges during this period is not the tragic decline that the doctors predicted, but a strange kind of flowering. Stephen's work on cosmology takes on new dimensions as he learns to think in ways that transcend his physical limitations. Unable to take extensive notes or work through calculations by hand, he develops an almost supernatural ability to manipulate complex equations in his head, to visualize mathematical relationships with a clarity that astonishes his colleagues. It's as if the disease that should have destroyed him is instead forcing him to discover capabilities he never knew he possessed. The body that once seemed so important, the hands that wrote equations, the voice that explained concepts, begins to seem less essential than the mind that generates the ideas. Stephen is learning, without yet realizing it, that consciousness is far more resilient and adaptable than anyone imagined. In October 1967, their first child is born. Robert George Hawking arrives with the perfect timing of someone who understands dramatic impact. Healthy, alert, and completely unimpressed by his father's growing fame in the cosmology community. Stephen holds his son with hands that shake slightly from his condition, but his face reflects a wonder that has nothing to do with theoretical physics and everything to do with the miracle of new life. The birth of Robert transforms Stephen's relationship with his own mortality in ways that surprise him. Suddenly, the prospect of death carries not just personal loss, but the weight of paternal responsibility. He wants to live not just for Jane, not just to complete his research, but to watch his son grow up, to be present for first words and first steps and all the small miracles that constitute a human childhood. This shift in perspective coincides with Stephen's first major breakthrough in theoretical physics. Working with Roger Penrose, he begins to develop what will become known as the singularity theorems, mathematical proofs that show how the universe itself must have begun from a point of infinite density and temperature, a moment when the normal laws of physics break down completely. It's fitting that Stephen's first great contribution to science involves understanding beginnings, because his personal life has become a masterclass in how endings can transform into new beginnings. The diagnosis that should have finished his story has instead become the prologue to something unprecedented, a life lived at the intersection of love and loss, hope and despair, human limitation and cosmic insight. Jane, meanwhile, completes her own transformation from young graduate student to the foundation upon which an extraordinary life is being built. She manages their household, raises their son, and somehow finds time to pursue her own academic interests, while also serving as Stephen's primary caregiver. But she does all this not as a martyr or a saint, but as a partner who has chosen to invest her life in something larger than herself. By the time their daughter Lucy is born in 1970, the 2-year death sentence has become a distant memory, replaced by a growing understanding that Stephen's disease may progress more slowly than anyone anticipated. More importantly, they've learned that a meaningful life isn't necessarily a long life, that significance comes not from the number of years you're given, but from how fully you inhabit the time you have. Stephen's work continues to flourish in ways that seem almost to mock his physical decline. The worse his body gets, the more clearly his mind seems to function. He develops an ability to see patterns and connections that elude his healthier colleagues, as if the approaching darkness has somehow sharpened his perception of the light. The love story between Stephen and Jane has become something more than romance. It's become a demonstration of human resilience, proof that the most powerful forces in the universe aren't always the ones that can be measured by instruments or described by equations. Sometimes the most transformative power is found in the simple decision to stay present, to keep loving, to refuse to let fear dictate the terms of existence. As we watch Stephen navigate these early years of marriage and fatherhood, we see the first evidence of a pattern that will define his entire life, the mysterious alchemy by which limitation becomes liberation, darkness becomes illumination, and love becomes the force that transforms everything it touches. The man who studies black holes is learning firsthand that even the most inescapable gravitational field can't contain the human spirit when it's fueled by love and purpose. Jane has given him something more precious than additional years of life. She's given him reasons to make those years count. In her presence, Stephen has discovered that he is not just a mind trapped in a failing body, but a complete human being capable of experiencing the full spectrum of human joy and connection. She's been the first light in his gathering darkness, and that light will continue to guide him toward discoveries that will illuminate the cosmos for millions of others. The foundation has been laid, love has taken root, and now, with Jane beside him and his children growing around him, Stephen is ready to turn his attention back to the deepest mysteries of existence, not as someone trying to escape from life, but as someone who has learned to embrace it fully, regardless of what the future might hold. Picture the Cambridge Mathematics Library on a winter morning in 1970, where shafts of pale sunlight filter through tall windows to illuminate dust motes dancing like tiny galaxies in the still air. At a corner table sits Stephen Hawking, now 28 years old, his walking stick propped against his chair as he leans forward over pages covered with equations that describe some of the most violent and mysterious phenomena in the universe. His handwriting has grown shakier, his speech more laboured, but his mind moves through the mathematics of curved space-time with the fluid grace of a dancer navigating familiar choreography. He's wrestling with questions that would have seemed like pure fantasy to previous generations of scientists. What happens when a star collapses under its own gravity? Can matter be compressed to infinite density? Is there a point where the familiar laws of physics simply surrender to something beyond human comprehension? These aren't abstract philosophical puzzles. They're mathematical realities hiding in Einstein's equations, waiting for someone with the courage to follow the math wherever it leads. The concept of black holes has been lurking in the shadows of theoretical physics since 1783, when a British clergyman named John Michell wondered what would happen if a star became so dense that light itself couldn't escape its gravitational pull. He called them dark stars, and for nearly 2 centuries they remained little more than a curious footnote in the margins of scientific possibility. But Einstein's general theory of relativity transformed these speculative entities into mathematical certainties, regions of space-time so fundamentally warped that they create cosmic prisons from which nothing, not even light, can ever escape. The name black hole itself wouldn't be coined until 1967 by physicist John Wheeler, and it captured something essential about these cosmic anomalies. They're not objects in the conventional sense. You can't touch them, photograph them, or observe them directly. They exist as absences, as holes punched through the fabric of reality itself. They reveal themselves only by their effects, the way they bend light around themselves like cosmic lenses, the spiraling dance of matter falling toward their invisible boundaries, the gravitational waves they send rippling through space-time when they collide. Stephen's fascination with black holes grows from his work with Roger Penrose, a brilliant mathematician whose mind moves through higher dimensions with the same ease most people navigate a familiar neighborhood. Together, they've been developing what will become known as the singularity theorems, mathematical proofs that show how the universe itself must have begun from a point of infinite density and curvature, where the normal rules of physics break down completely. Working with Penrose is like learning to see the universe through new eyes, where most people look at Einstein's equations and see impenetrable mathematical complexity. Penrose sees geometric beauty, the elegant curves and surfaces that describe how mass and energy warp the very structure of space and time. He teaches Stephen to think visually about abstract concepts, to imagine the topology of space-time as if it were a landscape he could walk through and explore. Their collaboration unfolds in long conversations that drift from blackboards covered with equations to walks along the River Cam, where Stephen moves more slowly than he once did, but his thoughts race ahead at light speed. They're exploring the mathematical boundaries of existence itself, the edges where space and time curve so sharply that they form horizons beyond which no information can ever return. These event horizons become cosmic one-way streets, allowing matter and energy to fall inward, while preventing any signal from ever escaping to tell us what lies within. The mathematics they develop is both beautiful and disturbing. Beautiful because it reveals deep connections between gravity, geometry, and thermodynamics that no one had suspected. Disturbing because it suggests that the universe contains regions that are fundamentally unknowable, places where the normal flow of cause and effect breaks down so completely that physics itself becomes meaningless. Stephen finds himself drawn deeper into this mathematical underworld, spending long hours contemplating the implications of horizons and singularities. His colleagues sometimes worry about the intensity of his focus. Here is a man whose own body is gradually shutting down, yet he chooses to study the cosmic equivalent of death and dissolution. But Stephen sees something different in black holes. To him, they're not symbols of destruction, but laboratories for testing the most fundamental principles of physics. Consider what happens when a massive star, say 130 times heavier than our Sun, reaches the end of its life. For millions of years, it has maintained a delicate balance between the inward pull of gravity and the outward pressure generated by nuclear fusion in its core. But eventually, the nuclear fuel runs out. The fusion fires that have kept the star inflated against its own gravitational pull begin to flicker and die. What follows is one of the most violent events in the universe. Without the pressure of radiation to support it, the star's core collapses in a fraction of a second, falling inward at speeds approaching that of light itself. The outer layers, no longer supported by the core's heat and pressure, follow suit, compressing matter to densities that beggar the imagination. In the space of heartbeats, a sphere of matter larger than Earth gets squeezed into a region smaller than Manhattan, then smaller than a city block, then smaller than a building. But the collapse doesn't stop there. If the star is massive enough, no force in the universe can halt the gravitational avalanche. The matter continues to compress, its density approaching infinity, its gravitational field growing so intense that it begins to warp space-time itself. At some point, a point defined by equations that Stephen knows by heart, the curvature of space-time becomes so extreme that it seals itself off from the rest of the universe. An event horizon forms, an invisible boundary in space marking the point of no return. Anything that crosses this threshold, matter, energy, even light itself, becomes trapped forever. From the outside, the collapsing star appears to freeze at the horizon, its light redshifting toward longer and longer wavelengths until it fades from view. But this is just an illusion, created by the extreme warping of time near the black hole. For anyone unfortunate enough to fall past the event horizon, the journey continues inexorably toward the center, toward a point where all the collapsed matter has been compressed to infinite density, a mathematical pathology called a singularity. Stephen spends countless hours contemplating what such a singularity might actually represent. The mathematics suggests a point where space and time themselves break down, where the curvature of space-time becomes infinite and the normal laws of physics cease to apply. It's a concept that pushes human language to its breaking point. How do you describe a place where the very concepts of place and when lose their meaning? But rather than being discouraged by these mathematical infinities, Stephen is energized by them. They represent the ultimate frontier, the deepest mystery that physics has to offer. If you can understand what happens at a singularity, you might unlock secrets about the fundamental nature of reality itself. And if black holes are laboratories for studying extreme physics, then they're exactly where a theoretical physicist should be focusing his attention. The work is demanding in ways that go beyond mere intellectual challenge. Stephen's condition continues to deteriorate, making it increasingly difficult to write equations by hand or work through lengthy calculations. But this physical limitation forces him to develop new ways of thinking about mathematics, more intuitive, more visual, more reliant on pattern recognition than brute computational force. He learns to hold complex equations in his mind like three-dimensional sculptures, rotating them mentally to see them from different angles, manipulating them through pure thought. His colleagues begin to notice something remarkable happening. As Stephen's body grows weaker, his mathematical intuition seems to grow stronger. He develops an almost supernatural ability to see connections that others miss, to leap directly to the heart of a problem without getting bogged down in technical details. It's as if the disease that should be clouding his thinking is instead clarifying it, stripping away everything non-essential and leaving only the pure essence of mathematical insight. Jane watches this transformation with a mixture of pride and concern. She sees her husband diving deeper into abstractions that seem increasingly removed from the physical world they share. Yet she also recognizes that this work is more than just academic exercise for him. It's become a form of transcendence, a way of touching something eternal and unchanging, despite the temporary nature of his physical existence. Their home life settles into rhythms shaped by the competing demands of cosmic contemplation and domestic reality. Stephen works when he can, taking breaks to play with young Robert and later with Lucy, who arrives in 1970 like a small miracle of perfectly timed chaos. There's something profoundly moving about watching Stephen hold his daughter, his hands trembling slightly from his condition, but his face radiant with the kind of wonder that no amount of theoretical knowledge can diminish. The children ground him in ways that pure mathematics cannot. When Robert asks why the sky is blue or Lucy wonders where babies come from, Stephen finds himself explaining concepts that he normally explores through equations filled with Greek letters and integral signs. These conversations teach him to think about complex ideas in simple terms, a skill that will prove invaluable in the years to come. But it's his work on black holes that increasingly dominates Stephen's intellectual landscape. Working with other brilliant minds like Brandon Carter and Werner Israel, he begins to develop what will become known as the laws of black hole mechanics, mathematical relationships that describe how these cosmic entities behave under various conditions. The first law relates changes in a black hole's mass to changes in its surface area and angular momentum. It's similar to the first law of thermodynamics, which describes how energy is conserved in ordinary physical systems. The second law states that the surface area of a black hole can never decrease. It can stay the same, or grow larger, but it can never shrink. This, too, has an analogue in thermodynamics, where the entropy of a closed system can never decrease. The parallels are more than mathematical curiosities. They hint at deep connections between black holes and thermodynamics that no one fully understands. Stephen finds himself wondering whether these similarities are mere coincidences or signs of some more fundamental relationship between gravity, information, and the nature of reality itself. It's during this period that Stephen first encounters the work of Jacob Bekenstein, a graduate student at Princeton who has the audacity to suggest that black holes might actually have temperature and entropy, thermodynamic properties that seem to make no sense for objects that are, by definition, perfectly black and featureless. Bekenstein's ideas initially strike Stephen as absurd. How can something have temperature if it doesn't radiate? How can something have entropy if no information can ever escape from it? The debate between Stephen and Bekenstein becomes one of those scientific disagreements that pushes both participants toward deeper understanding. Stephen marshals his formidable mathematical skills to argue against Bekenstein's proposals, while Bekenstein persists with the quiet determination of someone who senses he's onto something profound. Their exchanges, conducted through scientific papers and conference presentations, have the intensity of theological debates. They're not just arguing about the properties of exotic cosmic objects, but about the fundamental nature of information, entropy, and physical law. Meanwhile, Stephen's reputation within the physics community continues to grow. His work on singularity theorems has established him as one of the leading experts on the mathematical structure of space-time, while his investigations into black hole mechanics have opened up entirely new avenues of research. Colleagues who once knew him primarily as Dennis Sayama's promising graduate student now recognize him as a major voice in theoretical physics. The transformation is particularly striking given the progression of his disease. By 1973, Stephen requires a wheelchair for mobility, and his speech has become difficult enough that only those who know him well can easily understand what he's saying. Yet his scientific productivity reaches new heights. It's as if the physical constraints on his body have somehow liberated his mind, allowing it to soar into mathematical realms that few others can even imagine. There's something almost mystical about watching Stephen work during this period. He sits in his wheelchair surrounded by books and papers, his head tilted at an angle that allows him to see the blackboard where equations sprawl across the surface like abstract art. His hands, no longer steady enough for detailed writing, gesture expressively as he explains concepts to students and colleagues. The words come slowly now, each one carefully chosen and precisely articulated, despite the physical difficulty of speech. But it's clear that something extraordinary is building within his mathematical consciousness. The various threads of his research, singularity theorems, black hole mechanics, thermodynamic analogies, are beginning to weave together into a pattern that he can sense but not yet fully articulate. He's standing at the threshold of a discovery that will revolutionize our understanding of black holes and fundamentally alter the relationship between quantum mechanics and general relativity. The pieces are almost in place. The mathematical framework is nearly complete. All that remains is for Stephen to make the conceptual leap that will transform black holes from cosmic graveyards into cosmic lighthouses, the insight that will reveal how even the darkest objects in the universe secretly glow with their own gentle radiance. Ancient mythologies spoke of heroes who journeyed into the underworld and returned bearing gifts of wisdom for the living. Stephen Hawking, in his wheelchair, surrounded by equations that describe the cosmic equivalent of death itself, is about to make such a journey. He's about to descend into the mathematical underworld of black holes and emerge with a revelation so profound that it will illuminate not just these cosmic mysteries, but the very nature of reality itself. The stage is set, the mathematics is in place, and somewhere in the intricate dance between general relativity and quantum mechanics, a light is about to emerge from the deepest darkness the universe has to offer, a light that will bear Stephen's name and transform our understanding of everything from the smallest scales of quantum foam to the largest structures of cosmic evolution. The void is about to reveal its most precious secret, that darkness itself is luminous, that even nothingness glows with possibility, and that the universe's most perfect prisons are also its most generous teachers. Picture a quiet evening in 1974, somewhere in the gentle countryside outside Cambridge, where Stephen sits in his study surrounded by the familiar comfort of books and papers, the soft glow of a desk lamp creating a pool of warm light in the gathering dusk. Through the window, stars are beginning to emerge in the darkening sky, distant suns whose light has travelled for years or centuries to reach his eyes. But tonight, Stephen isn't looking outward toward those stellar beacons. Instead, his mind is turned inward, following mathematical pathways that wind through the strange landscape of quantum mechanics and general relativity, two theories that describe reality so differently they seem to inhabit separate universes entirely. His wheelchair is positioned at just the right angle to let him see the blackboard, where equations sprawl across the surface like hieroglyphs, spelling out the secrets of space-time. His hands, no longer steady enough for detailed calculations, rest quietly in his lap, while his mind performs mathematical gymnastics that would challenge even the most sophisticated computers. The physical world has grown smaller around him, his voice softer, his movements more restricted. But paradoxically, the universe of his thoughts has expanded beyond all previous boundaries. For months now, Stephen has been wrestling with a problem that seems almost designed to drive theoretical physicists to distraction. It's the question of what happens when you try to marry quantum mechanics, the theory that describes the bizarre behavior of matter and energy at the smallest scales, with general relativity, Einstein's elegant description of gravity as the curvature of space-time. These two pillars of modern physics make wildly different predictions about reality, and nowhere do their contradictions become more apparent than at the edge of a black hole. Quantum mechanics tells us that empty space isn't really empty at all. Even in the most perfect vacuum imaginable, the uncertainty principle ensures that pairs of particles are constantly popping into existence, borrowing energy from the quantum foam that underlies all of reality. These virtual particles appear in perfectly matched pairs, a particle and its antiparticle that normally exist for only the briefest instant before annihilating each other and returning their borrowed energy to the vacuum. It's a process so fleeting, so deeply buried in the quantum substrate of existence, that it would seem to have no relevance to the massive classical world of black holes and curved space-time. But Stephen has been wondering, what happens to these virtual particle pairs when they appear near the event horizon of a black hole? What occurs when the quantum foam meets the most extreme gravitational field in the universe? The mathematics required to answer this question pushes Stephen to the very limits of his abilities. He must somehow combine the probabilistic, wave-like descriptions of quantum mechanics with the geometric language of general relativity. It's like trying to write a poem that's simultaneously in English and Chinese, using two completely different alphabets to describe the same ineffable truth. Night after night, Stephen works through the calculations in his head, his phenomenal memory allowing him to hold dozens of complex equations in perfect clarity, while his intuition guides him through mathematical territories that no human being has ever explored. Jane sometimes finds him sitting motionless in his chair for hours, his eyes focused on some invisible landscape that exists only in the realm of pure mathematics, his breathing so quiet she has to watch carefully to make sure he's still with her. The breakthrough comes, as breakthroughs often do, with a sudden shift in perspective that transforms everything that came before. Stephen is thinking about the event horizon, that invisible boundary around a black hole where space and time become so warped that nothing, not even light, can ever escape. From the outside, this horizon appears to be a static, eternal barrier, but Stephen realizes that from the perspective of quantum mechanics, something extraordinary must be happening there. Picture what occurs when a virtual particle pair appears just at the edge of the event horizon. Under normal circumstances, these paired particles would exist for a tiny fraction of a second before finding each other again and annihilating back into nothingness. But near a black hole, the intense gravitational field can separate them before they have a chance to meet. One particle might fall past the event horizon, doomed to spiral inward toward the central singularity. The other particle, suddenly bereft of its partner, has no choice but to become real, to transform from a fleeting quantum possibility into an actual particle that can escape to infinity. The implications hit Stephen with the force of a revelation. If this process is constantly occurring all around the event horizon, then black holes aren't perfectly black at all. They must be radiating, emitting a steady stream of particles that carry energy away from the black hole and out into the wider universe. The cosmic prisons that trap even light itself are secretly glowing with their own gentle radiance. But the mathematics reveals something even more extraordinary. The temperature of this radiation, the characteristic energy of the particles being emitted, is inversely proportional to the mass of the black hole. Smaller black holes glow more brightly than larger ones. A black hole with the mass of our Sun would have a temperature of about 60 billionths of a degree above absolute zero. So cold it would be invisible against the cosmic microwave background radiation left over from the Big Bang, but a black hole with the mass of a mountain would burn as hot as the Sun's surface, while one with the mass of a large asteroid would blaze with the fury of a nuclear explosion. Stephen stares at his equations, hardly daring to believe what they're telling him. He's discovered that the ultimate symbol of cosmic death, the black hole from which nothing can escape, is actually alive with quantum fire. The darkest places in the universe are secretly the most luminous, glowing with a radiation that will eventually carry away all their mass and energy, causing them to evaporate completely over vast spans of cosmic time. The poetic justice of the discovery isn't lost on him. Here he is, a man whose body is gradually shutting down, imprisoned by a disease that grows stronger while he grows weaker. Yet his mind has just revealed that even the universe's most perfect prisons eventually open their doors. The parallel between his personal situation and his cosmic discovery seems almost too perfect to be coincidental, as if the universe itself is trying to teach him something about the relationship between darkness and light, imprisonment and liberation. But Stephen is too good a scientist to let poetry override physics. He checks and rechecks his calculations, approaching the problem from different angles, using different mathematical techniques, searching for any flaw that might invalidate his startling conclusion. The mathematics, however, remains stubbornly consistent. Black holes radiate. The conclusion seems inescapable. When Stephen first presents his results to the physics community, the reaction is a mixture of fascination and skepticism that borders on disbelief. He's claiming that objects defined by their inability to emit anything are actually radiating like cosmic furnaces. It's as counterintuitive as saying that perfect mirrors actually glow, or that the most soundproof rooms in the world are actually humming with music. The skepticism is understandable. For decades, physicists have thought of black holes as cosmic endpoints, places where matter and energy go to disappear forever. The idea that these ultimate sinks might actually be sources of radiation challenges some of the most basic assumptions about how the universe works. If black holes can radiate, then they can lose mass. If they can lose mass, then they can shrink. If they can shrink, then they can eventually evaporate completely, returning all their captured matter and energy to the universe in the form of thermal radiation. The implications ripple outward like waves from a stone dropped in still water. If Stephen is right, then the universe is far more dynamic than anyone imagined. Black holes aren't permanent fixtures in the cosmic landscape, but temporary phenomena that form, grow, and eventually fade away like everything else. Given enough time, vastly more time than the current age of the universe, but finite time nonetheless, even the most massive black holes will eventually evaporate in a final burst of radiation, leaving nothing behind but fading photons and the memory of what once was. But there's an even deeper mystery lurking in Stephen's equations. As a black hole radiates away its mass, it also carries away information about everything that ever fell into it. Every star that spiraled past the event horizon, every planet that was consumed, every pattern of matter and energy that disappeared into the gravitational abyss, all of it encoded somehow in the outgoing radiation. This seems to violate one of the most fundamental principles of quantum mechanics, that information can never be truly destroyed, only transformed from one form to another. The information paradox, as it comes to be known, will haunt Stephen for the rest of his career. It represents a deep tension between general relativity and quantum mechanics that no one has yet been able to resolve. According to general relativity, anything that falls past an event horizon is gone forever, its information lost to the outside universe. According to quantum mechanics, information can never be destroyed, only shuffled around in increasingly complex ways. Both theories can't be right, yet both have been tested to extraordinary precision in their respective domains. Stephen finds himself at the center of a debate that goes to the very heart of physics. Is information fundamental to reality, or is it an emergent property that can disappear under extreme conditions? Are there limits to what we can know about the universe, or are there always hidden channels through which information finds a way to survive? These aren't just technical questions for specialists. They touch on the deepest mysteries of consciousness, memory, and what it means for something to exist. Meanwhile, the radiation that bears Stephen's name becomes one of the most celebrated predictions in theoretical physics, even though it has never been directly observed. The Hawking radiation from stellar mass black holes is so faint that detecting it would require instruments far more sensitive than anything currently imaginable. But the theoretical framework Stephen has developed opens up entirely new ways of thinking about black holes, quantum mechanics, and the relationship between information and gravity. The discovery also transforms Stephen's place in the scientific community. He's no longer just a promising young researcher working on esoteric problems in mathematical physics. He's become the man who revealed that black holes glow, who showed that the darkest places in the universe are secretly luminous. His name begins appearing in textbooks alongside those of Einstein, Schrödinger, and other giants of physics. There's something profoundly moving about watching Stephen navigate this period of growing recognition. His physical condition continues to deteriorate. His speech becomes more difficult to understand, his mobility more restricted, yet his intellectual powers seem to reach new heights. It's as if the constraints on his body have somehow liberated his mind, allowing it to soar into mathematical realms that few others can even imagine. Jane watches this transformation with a mixture of pride and concern. She sees her husband becoming a figure of international scientific importance, yet she also sees the toll that this intense mental work takes on someone whose physical resources are increasingly limited. The equations that describe black hole radiation exist in Stephen's mind as living, breathing entities that demand constant attention and care. Even during family dinners or quiet evenings at home, she can see part of his consciousness dwelling in those abstract mathematical spaces where virtual particles dance at the edge of event horizons. Their children, Robert and Lucy, grow up in a household where discussions of quantum mechanics and general relativity are as common as conversations about school and playmates. They develop an intuitive familiarity with concepts that challenge even graduate students in physics, not because they're necessarily more intelligent than other children, but because they've absorbed these ideas through daily exposure to their father's work. There's something beautiful about watching Stephen explain his discoveries to his young children. The same mind that can manipulate tensor equations with supernatural facility also has a gift for finding simple analogies that make complex concepts accessible to anyone willing to listen. He tells Robert and Lucy about the virtual particles that pop in and out of existence, like bubble emerging from a cosmic foam. He describes black holes as cosmic whirlpools that can trap light itself, yet somehow still manage to glow with their own gentle fire. The discovery of Hawking radiation also marks the beginning of Stephen's transformation from pure researcher to science communicator. He realizes that his work has implications that extend far beyond the narrow confines of academic physics. If black holes can evaporate, if the darkest places in the universe secretly glow, if information might be fundamental to reality in ways that no one previously understood, then these discoveries speak to deep human questions about the nature of existence, consciousness, and our place in the cosmic order. Ancient wisdom traditions have long taught that light emerges from darkness, that lotus flowers bloom in muddy waters, that spiritual illumination often comes through confronting our deepest fears. Stephen's discovery of black hole radiation embodies this ancient truth in the most literal way possible. He has shown that even the universe's most perfect manifestations of darkness are actually sources of light, faint and gentle perhaps, but real and eternal nonetheless. The mathematical journey that led to this revelation has also been a personal one, in following the equations wherever they led, regardless of how counterintuitive their implications might be. Stephen has learned something profound about the nature of truth itself. Reality, it seems, is far stranger and more wonderful than our everyday intuitions suggest. The universe delights in paradoxes, in situations where opposite truths coexist in perfect harmony. As 1974 draws to a close, Stephen sits in his study contemplating the strange new landscape he has discovered. Black holes that glow, darkness that radiates light, cosmic prisons that eventually unlock themselves through the subtle action of quantum mechanics. The equations scattered across his blackboard seem to pulse with their own inner illumination, as if they're trying to tell him that this is just the beginning, that there are even deeper mysteries waiting to be uncovered. He doesn't yet know that this discovery will define the rest of his career, that it will lead to a lifetime of wrestling with the information paradox and its implications for our understanding of reality. He doesn't know that it will make him famous far beyond the walls of academia, transforming him from a specialist into a figure of popular fascination and admiration. He doesn't know that the radiation bearing his name will become one of the most important concepts in theoretical physics, studied and debated for generations to come. What he does know, sitting there in the gathering darkness with only his desk lamp for company, is that he has glimpsed something extraordinary. He has seen that the universe is far more generous than anyone imagined, that even its most selfish phenomena eventually give back what they have taken. In the gentle glow of Hawking radiation, he has found a cosmic metaphor for hope itself, the promise that no darkness is ever complete, no prison ever perfect, no ending ever truly final. The man who studies black holes has discovered that they shine, and in that discovery, he has illuminated not just a corner of theoretical physics, but something essential about the nature of existence itself. The light finds a way, always and everywhere, even from the heart of the deepest darkness. Picture Stephen in 1985, sitting quietly in his wheelchair beside a hospital bed in Geneva, Switzerland, where the rhythmic sound of machines marks time like a mechanical heartbeat. Outside the window, Lake Geneva stretches toward distant mountains capped with snow that catches the afternoon light and holds it like crystallized hope. But inside this sterile room, Stephen faces a choice that will transform not just his own life, but the way millions of people around the world understand their place in the cosmos. The pneumonia that brought him here has subsided, but it has left behind damage that requires a terrible decision. His breathing has become so labored, his airways so compromised, that the doctors are recommending a tracheostomy, a surgical procedure that will save his life but take away the last remnant of his natural voice. For a man whose career has been built on communication, on the ability to share cosmic insights through carefully chosen words, this seems like the cruelest possible irony. Jane sits beside him, her hand resting gently on his arm, as they contemplate a future that suddenly looks very different than anything they had imagined. Stephen's speech has been growing more difficult to understand for years, but it was still his voice, still carrying the inflections and rhythms that made his explanations of black holes and quantum mechanics feel like intimate conversations about the deepest mysteries of existence. Now that voice, already weakened by disease, faces complete silence. The medical team explains the procedure with clinical precision, outlining how the tracheostomy will allow Stephen to breathe more easily, but will make speech nearly impossible. They speak of quality of life and practical considerations, of the physical realities that Stephen's condition imposes on any decision about his future. What they cannot measure or account for is the transformation that's about to unfold, how the loss of his natural voice will become the catalyst for finding a voice that reaches farther than he could ever have imagined. Stephen makes the choice with the same quiet courage that has characterized his response to every challenge his disease has presented. The surgery proceeds without complications, and when he wakes, the silence is complete. The man who has spent his career explaining the music of the spheres, who has found poetry in the mathematics of curved space-time, who has revealed that even black holes sing with their own gentle radiation, can no longer speak. But the universe, it seems, has other plans. Walt Voltosh, a computer programmer from California, learns about Stephen's situation and reaches out with an offer that seems almost too perfect to be mere coincidence. He has developed a program called Equalizer, that allows people to construct sentences by selecting words from a screen, communicating through a speech synthesizer that transforms text into audible words. It's primitive by today's standards, but in 1985 it represents a miraculous bridge between thought and expression. The first time Stephen hears his new computer-generated voice, there's a moment of recognition that goes beyond mere acceptance of technological necessity. The voice is mechanical, emotionless, speaking in the flat cadences of early speech synthesis. Yet somehow it suits him perfectly. This is the voice of pure thought, of mind unencumbered by the physical limitations of flesh and vocal cords. It's as if the universe has given him an instrument perfectly calibrated to his needs, a voice that never tires, never slurs, never betrays the weakness of his failing body. Learning to use the system requires patience and determination. Stephen must spell out each word letter by letter, selecting from a grid of possibilities displayed on a screen. Simple sentences that once took seconds to speak now require minutes to construct, but the technology also forces him to choose his words with extraordinary care, to distill complex ideas down to their essential elements. Every sentence becomes an exercise in clarity and precision. Jane watches this adaptation with a kind of wonder reserved for witnessing true transformation. The Stephen she married could speak rapidly, sometimes faster than his thoughts could organize themselves, words tumbling out in cascades of excitement about cosmic discoveries. This new Stephen speaks more slowly, more deliberately, but with an authority that seems to come from having wrestled each word from silence and found it worthy of expression. The children, Robert now 18, Lucy 15, and young Timothy just 6, adjust to their father's new voice with the resilience that comes naturally to those who have grown up expecting change. They learn to read the subtle cues that indicate when Stephen is composing a thought, to wait patiently for the mechanical voice to deliver sentences that often contain wisdom worth the waiting. Timothy, in particular, seems to have an intuitive connection with the synthesizer, sometimes able to predict what his father is trying to say before the words appear on the screen. But it's in his scientific work that Stephen's new mode of communication proves most transformative. The enforced deliberation of computer-mediated speech changes the way he approaches complex ideas. Unable to rely on spontaneous verbal gymnastics, he must think through each concept completely before attempting to express it. The result is a crystalline clarity of thought that makes his ideas more accessible to colleagues and students alike. More importantly, Stephen begins to realize that his synthesized voice might be the key to reaching audiences far beyond the narrow confines of academic physics. The mechanical precision of the computer eliminates the barriers that his increasingly slurred speech had been creating, making his ideas comprehensible to anyone willing to listen. For the first time in years, he can communicate with perfect clarity, and the possibilities this opens up are staggering. It's during this period of technological adaptation that Stephen begins working on what will become a brief history of time. The idea emerges gradually, growing out of conversations with editors and publishers who recognize that there's a hunger in the general public for understanding the deepest questions about the universe. People want to know how everything began, whether time travel is possible, what happens at the center of a black hole. They want to understand not just what scientists have discovered, but what these discoveries mean for human existence. The challenge is immense. How do you explain concepts that challenge professional physicists to people who might not have studied mathematics beyond high school? How do you make the expanding universe feel as real and immediate as the morning sunrise? How do you transform equations filled with Greek letters and integral signs into stories that capture the imagination while remaining scientifically accurate. Stephen approaches the task with the same methodical patience he brings to all his work. Night after night, he sits in his study surrounded by earlier drafts and reference materials, crafting sentences that must carry complex ideas across the vast gulf between specialist knowledge and general understanding. The computer voice forces him to imagine how each word will sound to someone hearing these concepts for the first time, to anticipate the questions and confusions that might arise. The writing process becomes a meditation on the nature of communication itself. Stephen discovers that the most profound ideas often have the simplest expression, that the universe's deepest mysteries can be illuminated through careful attention to language and metaphor. He learns to think of his readers not as students to be educated, but as fellow travellers on a journey of cosmic discovery. Jane becomes his first and most important critic, reading each chapter as it emerges and offering feedback from the perspective of someone who is intelligent and curious, but not professionally trained in theoretical physics. Her questions force Stephen to rethink assumptions, to find new ways of explaining concepts that make sense to him but might confuse others. Together they craft a narrative that weaves together the personal and the cosmic, showing how questions about the nature of time and space connect to fundamental human concerns about meaning and mortality. The book takes shape slowly, each chapter emerging from months of careful revision and reconsideration. Stephen writes about the expanding universe as if he were describing the view from a cosmic observation deck, making billions of years of stellar evolution feel as immediate as watching clouds drift across the afternoon sky. He explains black holes not as abstract mathematical constructs, but as cosmic laboratories where the most extreme physics in the universe plays out, according to rules that are simultaneously strange and beautiful. Most remarkably, he managed to discuss his own discoveries, particularly Hawking radiation, without overwhelming readers with technical details or mathematical formalism. The virtual particles that appear at event horizons become characters in a cosmic drama, their behavior governed by quantum mechanical principles that Stephen presents as natural consequences of the universe's fundamental structure. When A Brief History of Time is published in 1988, neither Stephen nor his publishers expect the extraordinary response that follows. The book doesn't just find an audience, it creates one, awakening a hunger for cosmic understanding that crosses all boundaries of age, education, and cultural background. Within months, it climbs bestseller lists around the world, translated into dozens of languages, and read by millions of people who had never before considered the possibility that they might understand the deepest workings of reality. The success is unprecedented for a science book. Stephen finds himself invited to television shows, featured in magazines, recognized on streets, by people who want to thank him for making the universe accessible to them. The mechanical voice that emerged from such personal loss has become one of the most recognizable sounds in the world, carrying ideas about space and time to audiences that include everyone from school children to heads of state. But perhaps more importantly, Stephen discovers that his new mode of communication has given him something he never expected: perfect accessibility. The computer voice that once seemed like such a limitation has actually eliminated the barriers that physical speech can create. People listening to his synthesizer don't hear the effects of motor neuron disease. They hear pure thought, ideas unfiltered by the accidents of biology and circumstance. There's something deeply moving about watching Stephen navigate this transformation from private researcher to public figure. His physical condition continues to deteriorate. He now requires full-time care, can move only his eyes and some facial muscles, can no longer operate his wheelchair independently. Yet his intellectual presence has never been stronger. The man who once studied cosmic darkness has become a beacon of illumination for millions of people seeking to understand their place in the universe. Television appearances become exercises in technological ballet. Stephen's assistant operates the speech synthesizer, while he composes responses by moving his eyes to select letters and words. The process is slow but mesmerizing, creating dramatic pauses that give his words additional weight and authority. When he finally speaks, the mechanical voice carries ideas with a clarity and precision that make complex physics sound like universal truths. Audiences respond to something beyond just the content of Stephen's message. They sense the extraordinary human story behind the synthesized words, the courage required to continue pushing forward in the face of progressive disability, the determination to transform personal limitation into universal communication. His presence becomes a living demonstration that consciousness is far more resilient and adaptable than our physical assumptions suggest. The fame brings its own challenges. Stephen's home becomes a destination for journalists, documentary filmmakers, and curious admirers who want to meet the man behind the mechanical voice. Jane finds herself managing not just a household and Stephen's care, but also a constant stream of public demands on their time and attention. The quiet, academic life they once knew transforms into something more complex and demanding. Yet Stephen embraces his role as science communicator with genuine enthusiasm. He recognizes that his unique position, brilliant scientist, compelling personal story, perfectly clear artificial voice, gives him unprecedented opportunities to share the wonder of cosmic discovery. Each television interview, each public lecture, each encounter with curious strangers becomes a chance to kindle the same sense of awe that first drew him to physics. Children, in particular, respond to Stephen with an intuitive understanding that goes beyond the obvious drama of his situation. They seem to recognize something essential in his computerized communication, the voice of curiosity itself, unencumbered by adult assumptions about what's possible or impossible to understand. Their questions often cut straight to the heart of cosmic mysteries. Why is there something rather than nothing? What happened before the Big Bang? Is time travel really impossible? Stephen discovers that answering these questions for young audiences forces him to think about his own work in new ways. The mathematical formalism that dominates academic physics melts away, leaving only the essential insights about how reality operates at its deepest levels. In explaining black holes to a 10-year-old, he must find the poetry that exists within the equations, the human drama that unfolds in cosmic catastrophes. The process of becoming a public figure also teaches Stephen something profound about the relationship between personal experience and universal truth. His own journey from terminal diagnosis to global recognition mirrors themes that run throughout his scientific work: the transformation of darkness into light, the emergence of complexity from simplicity, the tendency for the universe to generate beauty and meaning even in the most unlikely circumstances. By the end of the 1980s, Stephen has completed a transformation that seemed impossible just a few years earlier. The man who lost his voice has found a way to speak to the entire world. The researcher who studied the darkest places in the universe has become a source of illumination for millions of people. The patient who was given 2 years to live has survived to share cosmic insights that will outlive any individual lifespan. Ancient traditions speak of wounded healers, those who transform personal suffering into universal wisdom, who find in their own darkness the light that can guide others. Stephen Hawking has become such a figure, not through mystical insight or spiritual revelation, but through the methodical application of scientific thinking to the deepest questions about existence. His synthesized voice carries across cultural and linguistic boundaries, translating the abstract mathematics of theoretical physics into stories that touch something fundamental in human consciousness. The universe, it seems, has a sense of irony as elegant as any equation. The man who discovered the black hole's glow has himself become a source of light, illuminating cosmic mysteries for anyone willing to listen. The voice that emerged from silence speaks more clearly than ever before, carrying whispers from the edge of space-time to anyone curious enough to wonder about their place in the vast, strange, beautiful cosmos we all share. Picture Stephen in the mid-1990s, bathed in the golden afternoon light that streams through his Cambridge office windows, casting long shadows across whiteboards covered in equations that look like cosmic hieroglyphs. His wheelchair sits at the centre of what has become perhaps the most famous room in theoretical physics, a space where the walls seem to pulse with accumulated wisdom, where books lean against each other like old friends sharing secrets, where the very air seems charged with the electricity of profound thoughts taking shape. The sunlight catches the dust motes floating through the room, and for a moment they resemble the virtual particle pairs Stephen discovered dancing at the edge of black hole event horizons, appearing from nothingness, existing in brief luminous moments before disappearing back into the quantum foam. There's something almost mystical about this office, as if the boundary between mathematical abstraction and physical reality has grown thin here, allowing glimpses of the universe's deepest structures to emerge in the space between one equation and the next. Stephen himself sits perfectly still in this cathedral of cosmic thought, his body now completely claimed by the disease that arrived more than 30 years ago with a 2-year death sentence. His hands rest motionless in his lap, fingers that once wrote equations now curved into gentle sculptures of repose. His head tilts at an angle that allows his eyes, still bright, still missing nothing, to track across the computer screen where words and symbols wait for his selection, like servants attending a silent king. Yet paradoxically, Stephen has never been more powerful. The voice that emerged from his silence has become one of the most recognizable sounds on Earth, carrying ideas about space and time across every cultural and linguistic boundary. Children in Tokyo know the mechanical cadence of his speech synthesizer. Scientists in Sao Paulo quote his equations in papers that push the frontiers of human knowledge. World leaders call seeking his counsel on questions that span from the fate of our planet to the future of artificial intelligence. The daily choreography of genius unfolds in this room with the precision of celestial mechanics. Each morning, graduate students arrive like pilgrims approaching a shrine, their faces carrying that particular mixture of excitement and nervousness that comes with working at the absolute edge of human understanding. They spread papers across tables, sketch diagrams on whiteboards, prepare to serve as extensions of Stephen's mathematical intuition. Watch him compose a thought, and you witness something that seems to transcend the normal boundaries of human limitation. His eyes move across the screen of letters and symbols, pausing here and there as if he's reading music written in the language of mathematics. Each selection, a letter, a word, an equation, emerges from contemplation so deep it seems to touch the substrate of reality itself. The process is slow, meditative, almost liturgical in its careful precision. The universe, he might spell out word by careful word, doesn't care about our limitations. The mechanical voice delivers this insight with the flat certainty of a computer, but somehow the words carry more weight than if they had emerged from organic vocal cords. It's as if pure thought is speaking, unfiltered by the accidents of biology. His students learn to read the subtle signals that indicate when Stephen is wrestling with particularly complex ideas. His eyes will focus on some invisible point in space, as if he's watching mathematical structures unfold in dimensions that only he can perceive. During these moments, the room falls into reverent silence, everyone understanding they're witnessing a mind operating at frequencies that few humans have ever accessed. Jane moves through this rarefied atmosphere with the grace of someone who has learned to navigate between the cosmic and the domestic, between the universal and the intensely personal. She manages a household that exists simultaneously as a family home and a kind of scientific mission control center. Breakfast conversations might drift from mundane concerns about grocery shopping to speculations about the information paradox that has been haunting Stephen's work for years. The information paradox has become Stephen's Moby Dick, a mystery so fundamental that solving it might require rebuilding the entire edifice of modern physics from its foundations. The question sounds deceptively simple. When matter falls into a black hole, what happens to the information it contains? Does it disappear forever, violating one of quantum mechanics' most sacred principles? Or does it somehow escape through the Hawking radiation encoded in ways we don't yet understand? Stephen approaches this puzzle with the same methodical patience he brings to everything, but there's an intensity to his focus that suggests he senses something profound, lurking just beyond the mathematical horizon. He collaborates with brilliant minds from around the world: James Hartle, Leonard Susskind, Juan Maldacena, each conversation conducted through the patient medium of his computerized voice, each exchange pushing deeper into territories that have never been explored by human consciousness. The work leads him to develop the no-boundary proposal with Hartley, a model of the universe so elegant and counterintuitive that even Stephen's colleagues struggle to grasp all its implications. Imagine space-time as finite but without edges, like the surface of a sphere extended into dimensions we can barely conceive. In this model, the Big Bang wasn't an explosion from a single point, but rather a smooth emergence from a quantum state that exists outside our normal concepts of space and time. Picture Stephen explaining this idea to a room full of physicists, his synthetic voice cutting through the academic atmosphere like a laser through morning mist. Asking what happened before the Big Bang, he might say, is like asking what lies north of the North Pole. The metaphor is simple, but it carries within it implications that could revolutionize our understanding of existence itself. But Stephen's concerns extend far beyond the abstract realms of cosmology and quantum mechanics. His unique position, brilliant scientist, global icon, living demonstration of consciousness transcending physical limitation, gives him a platform to address challenges that could determine humanity's future. He begins using his voice not just to explain the universe, but to warn about the dangers that could end our species' brief experiment with self-awareness. His warnings about artificial intelligence carry the weight of lived experience. Here is a man whose thoughts travel through computer interfaces, whose consciousness operates in constant partnership with technology, yet who understands better than most the subtle dependencies and potential dangers of human-machine cooperation. When Stephen speaks about AI, his mechanical voice carries an authority that purely organic warnings might lack. The development of full artificial intelligence he spells out during a BBC interview, each word selected with careful deliberation, could spell the end of the human race. The statement emerges from his synthesizer with the flat certainty of a mathematical theorem, but the implications ripple outward like gravitational waves from a cosmic collision. He's not speaking from technophobia or science fiction paranoia, but from deep understanding of intelligence as both a creative and potentially destructive force. There's profound irony in these warnings, coming from someone whose own intelligence operates through technological amplification. Stephen's computer voice allows him to communicate more clearly than his organic speech could in its final years. His screen-based interfaces let him manipulate equations with mathematical precision that handwriting could never match. Yet he recognizes that consciousness, even technologically mediated consciousness, requires something essentially human: intention, values, the kind of wisdom that emerges from wrestling with questions of meaning rather than mere computation. Climate change becomes another focus of Stephen's growing advocacy, viewed through the cosmic perspective that has always characterized his thinking. From the vantage point of someone who has spent decades studying planetary formation and stellar evolution, Earth's current trajectory looks deeply troubling. Stephen can see our planet's climate system with the same clarity he brings to black hole thermodynamics, as a complex system with tipping points and feedback loops that could lead to irreversible transformations. We are close to the tipping point, he warns during a lecture at Cambridge, where global warming becomes irreversible. His words emerge from the synthesizer like prophecies delivered by an oracle who has peered into the deep future. But these aren't mystical visions. They're conclusions drawn from the same mathematical rigor that revealed how black holes evaporate and how the universe might have emerged from quantum nothingness. Space exploration takes on new urgency in Stephen's thinking, driven not just by scientific curiosity, but by species survival. He argues that humanity needs to become spacefaring not as an abstract goal, but as an insurance policy against cosmic catastrophes that could end our civilization in an instant. Asteroid impacts, supernovae, gamma-ray bursts. The universe is full of phenomena that could sterilize Earth without warning. It's this concern for humanity's long-term survival that leads Stephen to one of the most memorable experiences of his later life, the zero-gravity flight of 2007. Picture him strapped into his wheelchair aboard a specially modified aircraft, surrounded by medical equipment and worried assistants, as the plane climbs steeply into the Florida sky. For most of his adult life, Stephen has been imprisoned by gravity, the same force he studies in its most extreme cosmic manifestations has become his personal jailer, pinning him to his wheelchair with inescapable persistence. But for 25 seconds during the plane's parabolic dive, that imprisonment ends. The wheelchair straps are released and Stephen floats free, his body finally liberated from the gravitational field that has been his constant companion. The photographs from that flight show him suspended in mid-air, his face radiating pure joy, his eyes bright with wonder at this momentary taste of the weightlessness that astronauts experience routinely, but which came to him as the rarest of gifts. It was amazing, he says afterward, his synthesizer somehow managing to convey excitement despite its mechanical limitations. I could have gone on and on. The experience connects him viscerally to the space exploration he advocates intellectually. For those brief moments, he has experienced what it might feel like to be truly free of Earth's gravitational embrace, to exist in the weightless environment where humanity's future might unfold. The flight also serves as a training run for Stephen's planned trip to space, a journey that sadly never materializes as his health declines, but which represents something profound about his refusal to accept limitations as permanent. Here is a man whose body has been systematically shut down by disease, yet who dreams of escaping Earth's gravity well entirely. The boy who once took apart alarm clocks has become a man who wants to dismantle the gravitational constraints that bind human consciousness to a single planet. Famous scientific bets become another expression of Stephen's playful relationship with cosmic mysteries. His wager with Kip Thorne about whether black holes exist, Stephen arguing they don't, hedging against his own life's work. His bet about the discovery of the Higgs boson, his speculation about the nature of naked singularities. These aren't just academic exercises, but expressions of a mind that remains fundamentally curious, willing to be wrong if it means learning something new about reality. When Stephen concedes the black hole bet, presenting Thorne with a subscription to Penthouse magazine as payment, there's something delightfully human about the gesture. This is the same man who revealed that black holes evaporate, who showed that the darkest places in the universe secretly glow, yet who maintains enough humility to admit when observations prove his speculations wrong. Timothy, now growing into adolescence, watches his father navigate this period of extraordinary productivity and public recognition with the kind of matter-of-fact acceptance that comes from growing up in proximity to genius. The mechanical voice that might seem strange to outsiders is simply Dad's voice to Timothy, carrying the same paternal authority and affection that any child recognizes in their parent's speech. Lucy, establishing herself as a writer and science communicator, collaborates with Stephen on children's books that translate cosmic mysteries into stories accessible to young minds. Together, they craft tales that make black holes feel as familiar as playground equipment, that transform the Big Bang into an adventure story suitable for bedtime reading. There's something beautiful about this partnership between father and daughter, both using their gifts with language to make the universe feel less alien and more welcoming to curious minds. Robert, pursuing his own career in academia, carries forward the family tradition of intellectual curiosity while carving out his own distinct path. He has inherited his father's analytical mind, but applies it to earthly rather than cosmic problems, showing that the capacity for deep thinking can manifest in many different fields of endeavour. Jane, meanwhile, finds herself increasingly stretched between the demands of managing Stephen's care and maintaining her own intellectual life. The man she married with a 2-year life expectancy has become a global phenomenon, whose needs extend far beyond what any single person can provide. The love that began as romantic attachment has evolved into something more complex, a mixture of devotion, duty, shared purpose, and growing recognition that their extraordinary circumstances require extraordinary solutions. As the 1990s progress into the new millennium, Stephen's physical condition continues its relentless decline, but his intellectual presence seems to grow stronger rather than weaker. It's as if consciousness, finding its normal channels increasingly restricted, has learned to flow through whatever pathways remain available with intensified clarity and purpose. The man who discovered that black holes glow has himself become a beacon whose light reaches every corner of human intellectual endeavour. His synthesized voice carries across cultural and linguistic boundaries, translating the deepest insights about cosmic reality into languages that speak to fundamental human concerns about meaning, mortality, and our place in the vast, strange, beautiful universe we inhabit. In his wheelchair, surrounded by equations and aided by technology, Stephen has achieved a kind of transcendence that seems almost mystical in its completeness. He has become pure mind in conversation with the cosmos, consciousness unencumbered by the normal limitations of flesh and time. The darkness that should have consumed him decades ago has instead become the source of illumination that continues to guide humanity toward deeper understanding of its cosmic inheritance. Picture Cambridge on a quiet morning in March 2018, where frost still clings to the ancient stones of Trinity Hall, and the river, Cam, flows with the patient persistence of time itself. In a house that has become a pilgrimage site for curious minds from around the world, Stephen Hawking sits in his wheelchair for what will be the last time, surrounded by the equations and books that have been his companions for more than 5 decades. The light filtering through his study windows carries the particular quality of early spring, soft, tentative, full of promises about renewal and continuation. At 76 years old, Stephen has lived more than 37 times longer than his doctors predicted when they delivered that devastating diagnosis on a cold day in 1963. The 2 years he was given have stretched into more than half a century, filled with discoveries that have illuminated the darkest corners of the universe and transformed our understanding of reality itself. Now, as his extraordinary journey approaches its end, there's something almost mystical about the way light and shadow play across the room, where so many cosmic insights first took shape in the infinite space of human consciousness. His breathing has grown more laboured in recent months, his body finally approaching the limits that even the most determined spirit cannot transcend. Yet his eyes remain bright, still capable of that particular intensity that comes when a brilliant mind encounters ideas worthy of its attention. The computer screen in front of him displays work in progress, equations exploring the information paradox that has captivated him for decades, mathematical attempts to understand what happens to consciousness when it encounters the event horizon of a black hole. The irony is almost too perfect to be accidental. Here is a man who has spent his career studying the ultimate boundaries, the edge of black holes, the beginning of time, the limits of what can be known about reality. And now he approaches the ultimate boundary of his own existence. Yet there's no sense of defeat in his presence, no suggestion that this ending represents failure. Instead, there's something that feels more like completion, as if a cosmic symphony that began with a single note in 1942 is finally approaching its natural resolution. Jane, now separated from Stephen but still connected by bonds that transcend the conventional categories of human relationship, visits regularly during these final months. Their love story, which began with such hope in the shadow of a terminal diagnosis, has evolved through decades of extraordinary circumstances into something more complex than romance, but no less profound. They've shared the journey from darkness to light, from a 2-year death sentence to global recognition, from private struggle to public inspiration. Watching them together during these last visits, you can see the ghostly outlines of the young couple who once defied medical predictions with nothing but love and determination. Jane's face still carries traces of the fierce beauty that first captured Stephen's attention across a crowded room in 1963, while Stephen's eyes retain the mischievous intelligence that made complex physics sound like intimate conversation about the deepest secrets of existence. Their children, Robert, Lucy and Timothy, have grown into adults who carry forward the family legacy of curiosity and intellectual courage in their own distinct ways. Robert has built a successful career in academia, applying the analytical gifts he inherited to earthly rather than cosmic problems. Lucy has become a renowned writer and science communicator, using her talents to make complex ideas accessible to young minds around the world. Timothy, the baby who arrived like a small miracle in 1979, has matured into someone who understands that his father belongs not just to their family, but to the entire human species. The household still pulses with the rhythms of scientific inquiry, even as Stephen's physical participation becomes increasingly limited. Graduate students continue to arrive each morning, carrying papers and ideas that need the touch of his extraordinary intuition. Colleagues from around the world communicate through email and video calls, seeking his insights on problems that push against the boundaries of human understanding. But there's a different quality to these interactions now, a sense that everyone involved recognizes they're participating in something that's drawing to a close. Stephen's responses come more slowly, require greater effort, yet somehow carry even more weight than before. Each word selected through his eye-tracking system seems to have been refined through contemplation so deep it touches the fundamental structures of reality. The work continues, but it takes on the character of legacy rather than active exploration. Stephen knows with the same mathematical certainty he brings to cosmic calculations that his time for making new discoveries is ending. Instead, he focuses on ensuring that his insights survive the transition from his individual consciousness to the broader stream of human knowledge. The information paradox remains unresolved despite decades of intensive investigation. Stephen has wrestled with this problem like Jacob wrestling with the angel, refusing to let go until it yields its secrets. The question of what happens to information that falls into a black hole has become more than just a technical puzzle. It's a meditation on the nature of knowledge itself, on whether there are truths that can be permanently lost to the universe, or whether information, like energy, can never be truly destroyed. In his final papers, Stephen continues to explore possibilities that push the boundaries of conventional thinking. Perhaps black holes don't have the sharp event horizons that general relativity suggests, but rather apparent horizons that allow information to escape through subtle quantum effects. Perhaps the holographic principle, the idea that all the information in a volume of space can be encoded on its boundary, provides a way for black holes to preserve rather than destroy the patterns that define physical reality. The mathematics required for these investigations pushes even Stephen's extraordinary capabilities to their limits. Working with younger colleagues who can provide the computational muscle his own condition no longer allows, he continues to probe questions that exist at the very edge of human knowledge. It's fitting that someone who has spent his career studying boundaries should approach the boundary of his own existence, still reaching toward new understanding. His warnings about artificial intelligence and climate change take on new urgency during these final years, as if Stephen recognizes that his unique voice will soon be silenced and wants to ensure his concerns are heard while there's still time. The mechanical speech synthesizer that has carried his thoughts to millions of people around the world continues to deliver messages about humanity's future with the same flat certainty it has always used for cosmic insights. We're probably nearing the end of human evolution, he says, during one of his final public appearances, his words emerging from the computer with their characteristic deliberate precision. We must not let artificial intelligence take over. The warning carries the weight of someone who has lived his entire adult life in partnership with technology, who understands better than most both its liberating potential and its subtle dangers. The climate change warnings flow from the same cosmic perspective that has always characterized Stephen's thinking. From the vantage point of someone who has studied planetary formation and stellar evolution, Earth's current trajectory looks deeply troubling. Stephen can see our planet's climate system with the same clarity he brings to black hole thermodynamics, as a complex system approaching tipping points that could trigger irreversible changes. Space exploration remains central to his vision for humanity's future, driven by the recognition that Earth, for all its beauty and complexity, remains vulnerable to cosmic catastrophes. The same forces that create the spectacular phenomena Stephen has studied, supernovae, gamma-ray bursts, asteroid impacts, could end human civilization in an instant. His advocacy for becoming a spacefaring species carries the urgency of someone who sees both cosmic and terrestrial threats converging on a time scale that could affect his own grandchildren. March 14th, 2018 arrives like any other early spring morning in Cambridge, with mist rising from the River Cam and students hurrying across courtyards that have witnessed centuries of intellectual discovery. But this morning carries a significance that seems almost too perfectly orchestrated to be mere coincidence. This is Einstein's birthday, March 14th, the same date that brought the greatest physicist of the previous century into the world in 1879. That Stephen chooses this day for his final departure feels like the universe completing a pattern that began with his birth on Galileo's death day. From Galileo to Einstein to Hawking, three minds separated by centuries yet connected by their shared ability to see beyond the comfortable illusions of their times, to peer into the fundamental structures of reality and return with insights that transform human understanding. The end comes quietly, in the early hours when the house sleeps and even the equations on his whiteboard seem to rest in peaceful suspension. There's no drama, no struggle against the inevitable, just the gentle cessation of the biological processes that have sustained one of the most extraordinary minds in human history. Stephen slips away with the same grace he brought to his life's work, his consciousness finally released from the physical constraints that have shaped and defined his earthly journey. The news spreads around the world with the speed of light itself, carried by the same digital networks that once transmitted Stephen's synthesized voice to audiences across every continent. Within hours, tributes begin pouring in from heads of state, fellow scientists, students, and countless ordinary people whose lives have been touched by Stephen's unique combination of intellectual brilliance and human courage. Cambridge falls into a kind of reverent silence as the reality settles in. The man who made this ancient university town the centre of theoretical physics for an entire generation will no longer be seen in his wheelchair, navigating between lectures and meetings with the patient determination that characterized everything he did. The mechanical voice that could make the birth of the universe sound like a bedtime story has been stilled forever. Yet even as the immediate shock of loss settles over the scientific community, there's a growing recognition that Stephen's true legacy extends far beyond his physical presence. The ideas he generated, the discoveries he made, the example he set, these continue to pulse through human consciousness, like gravitational waves propagating across the cosmos long after the events that created them. The funeral service at Great St. Mary's Church in Cambridge becomes a celebration not just of Stephen's life, but of the human capacity to transcend limitation through force of will and clarity of thought. Colleagues, family members, and admirers gather in the ancient space where Newton once worshipped, where generations of Cambridge scholars have gathered to mark life's most significant transitions. Eddie Redmayne, the actor who portrayed Stephen in The Theory of Everything, delivers a reading from Ecclesiastes with words that seem almost written for this moment. For everything there is a season and a time for every matter under heaven. The passage captures something essential about Stephen's journey, how his apparent catastrophe became the foundation for unprecedented achievement, how his deepest winter became the source of spring for millions of others. The memorial service at Westminster Abbey later that year draws an even more diverse gathering. Here, In this space where the greatest figures in British history are remembered, Stephen takes his place not just among scientists, but among the larger pantheon of human achievement. His ashes are interred between the graves of Newton and Darwin, creating a trinity of minds that fundamentally altered human understanding of the natural world. But perhaps the most fitting memorial is the ongoing work of the students and colleagues who continue to explore the questions Stephen first posed. In laboratories and lecture halls around the world, researchers build upon the foundations he established, pushing deeper into the mysteries of black holes, quantum mechanics, and the fundamental nature of space and time. The information paradox remains unresolved, waiting for some future genius to make the conceptual breakthrough that eluded even Stephen's extraordinary intuition. Young physicists continue to wrestle with the same questions that captivated him, driven by the same curiosity about the universe's deepest structures. In their work, Stephen's influence continues to propagate like the Hawking radiation he discovered. Invisible, perhaps, but real and eternal. The popular books he wrote, particularly A Brief History of Time, continue to find new readers in each generation. Children discover the wonder of cosmology through his gentle explanations of cosmic phenomena. Students encounter their first glimpse of serious physics through his gift for making complex ideas accessible without sacrificing their essential mystery. The Stephen Hawking Foundation, established to carry forward his mission of making science accessible to all, ensures that his commitment to education and public understanding continues to shape how humanity thinks about its place in the cosmos. Through scholarships, lectures, and outreach programs, the Foundation extends Stephen's influence into futures he will never see, but helped to shape. Technology companies continue to develop artificial intelligence systems that owe their existence in part to Stephen's early warnings about the need for careful, ethical development of machine intelligence. His concerns about AI safety help guide research in directions that maximize benefit while minimizing risk, ensuring that the technological revolution he foresaw unfolds in ways that serve rather than threaten human flourishing. Climate scientists cite his warnings about planetary tipping points as they work to understand and address the environmental challenges facing our species. The cosmic perspective he brought to earthly problems continues to inform efforts to preserve the only planet we currently call home, while also inspiring continued work toward the space exploration he saw as essential for long-term survival. Perhaps most importantly, Stephen's example continues to inspire anyone facing seemingly insurmountable challenges. His transformation from a young man given 2 years to live into one of history's most celebrated scientists demonstrates something profound about the resilience of human consciousness when allied with purpose and determination. The letters that pour into Cambridge from around the world in the months following his death tell a story that goes far beyond academic achievement. Parents write about children with disabilities who found hope in Stephen's example. Students describe how his books opened their minds to possibilities they never imagined. Scientists credit him with inspiring their career choices, their research directions, their commitment to making knowledge accessible to everyone. In a sense, Stephen has achieved a kind of immortality that transcends biological existence. His ideas continue to evolve through the work of others. His influence spreads through each new generation that encounters his insights. His example continues to demonstrate that human consciousness can transcend any limitation when focused on purposes larger than itself. The man who discovered that black holes glow has himself become a source of light that will continue shining long after its original source has been extinguished. In the gentle radiation that bears his name, in the students who carry forward his work, in the countless minds that have been illuminated by his insights, Stephen Hawking has achieved the kind of continuity that he explored in his physics, a transformation from one form to another without any loss of essential information. Late at night in Cambridge, when the ancient stones settle into silence and the River Cam flows past darkened colleges, you might imagine you can still hear the faint electronic whisper of a mechanical voice explaining the mysteries of existence to anyone curious enough to listen. The sound fades into the rustling of leaves and the distant hum of the modern world, but the ideas it carried continue to propagate through human consciousness like waves in the fabric of space-time itself. The universe is a little darker now that Stephen's light has been extinguished, but paradoxically it's also brighter, illuminated forever by the insights he generated during his extraordinary journey from diagnosis to discovery, from darkness to radiant understanding, from the prison of a failing body to the infinite freedom of a mind that learned to dance among the stars. In the end, Stephen Hawking became exactly what he studied, a source of radiation emerging from the deepest darkness, carrying information across vast distances, transforming everything it touches while slowly, gently, eternally giving its essence to the wider universe. His light will continue travelling through human consciousness for generations to come, a gentle reminder that even the darkest places can somehow, mysteriously, beautifully glow. Picture yourself now, settling deeper into whatever comfortable space has held you through this long journey into the extraordinary life of Stephen Hawking. Perhaps you're curled beneath blankets that have grown warm with your presence, or nestled in a chair that has moulded itself to your body's contours, while we've drifted together through more than 7 decades of cosmic discovery. The night outside your window may have deepened since we began, stars emerging one by one like distant memories of ancient light, each photon carrying stories from the deep past toward whatever futures await our curious species. We've travelled together from that cold January morning in 1942, when a baby's cry pierced the darkness of wartime Oxford, to March 2018, when the silence that followed his final breath seemed to echo around a world suddenly aware of what it had lost. 7.5 decades compressed into a few hours of gentle exploration, yet somehow the journey feels both complete and infinite, like looking into one of those mirrors that reflects endlessly back on itself, creating corridors of meaning that stretch beyond the boundaries of any single story. The transformation we've witnessed defies every conventional understanding of how human lives unfold. Here was a young man given 2 years to live, who instead discovered eternity in the mathematics of black holes, a student whose body began failing just as his mind was learning to soar into territories no human consciousness had ever explored, a husband and father who found in love not escape from his condition, but the strength to transform personal darkness into universal illumination. The disease that should have destroyed Stephen Hawking became instead the crucible in which something unprecedented was forged. Motor neuron disease, that cruel thief of movement and speech, somehow failed to touch the essential core of who he was. If anything, it seemed to clarify that core, stripping away everything non-essential until only the purest distillation of curiosity and courage remained. Like a sculptor removing marble to reveal the statue hidden within, ALS carved away Stephen's physical capabilities, only to reveal the radiant mind that had been there all along. There's something almost mystical about the parallels between Stephen's personal journey and his greatest scientific discovery. Both involved finding light in places where light was thought impossible. Both required seeing past surface appearances to recognize deeper truths. Both demonstrated that the universe's most perfect prisons, whether physical disability or cosmic event horizons, cannot contain the essential qualities that make existence meaningful. When Stephen first calculated that black holes must emit radiation, he revealed that the darkest places in the universe secretly glow with their own gentle fire. The cosmic graveyards that trap even light itself are actually sources of illumination, slowly returning their captured energy to the wider cosmos through the patient process of quantum evaporation. It's discovery that speaks to something fundamental about the nature of reality, that darkness is never complete, that isolation is never perfect, that even the most sealed systems eventually find ways to communicate with the outside world. The man who made this discovery embodied its deepest implications. Trapped within a body that grew more restrictive with each passing year, Stephen found ways to radiate insights that reached every corner of human consciousness. His mechanical voice became more recognizable than most organic ones, carrying ideas about space and time across every cultural and linguistic boundary. Like the Hawking radiation that bears his name, his influence was gentle but persistent, transforming everything it touched while seeming to emerge from emptiness itself. The speech synthesizer that replaced his natural voice became a perfect metaphor for his entire approach to limitation. Where others might have seen technology as a poor substitute for biological function, Stephen recognized it as liberation. The computer voice that never tired, never slurred, never betrayed physical weakness, became the instrument through which he could speak to the entire world with crystalline clarity. In losing his organic voice, he found a universal one. This transformation from constraint to freedom, from darkness to light, challenges our most basic assumptions about what constitutes a meaningful life. Stephen's story suggests that significance doesn't depend on physical capability, that influence doesn't require mobility, that the most profound communications can emerge from the deepest silence. He lived proof that consciousness is far more resilient and adaptable than we typically imagine, that the human spirit possesses resources that only become apparent when ordinary channels are closed. The children who grew up in Stephen's household learned these lessons simply by observing their father's daily existence. They saw how brilliance could operate through whatever channels remained available, how love could express itself through eye movements and computerized words, how authority could emerge from vulnerability rather than strength. Timothy, Lucy, and Robert inherited more than genetic material from their father. They absorbed a way of being in the world that refuses to accept limitation as permanent or definitive. Jane's role in this extraordinary story deserves its own contemplation. She made choices that most people would consider impossible, staying committed to a relationship that defied every conventional expectation about marriage and partnership. Her love wasn't blind to Stephen's condition, but somehow saw through it to something more essential and enduring. In choosing to build a life with someone whose body was failing, she demonstrated something profound about the nature of human connection, that it can transcend physical circumstances, that it can survive transformations that would destroy relationships built on less substantial foundations. The scientific legacy Stephen leaves behind extends far beyond any individual discovery or insight. He changed how we think about the universe's most extreme phenomena, revealing beauty and meaning in cosmic events that once seemed purely destructive. Black holes, those ultimate symbols of cosmic death, became through his work laboratories for understanding the deepest connections between quantum mechanics, thermodynamics, and the nature of information itself. But perhaps more importantly, Stephen changed how we think about the process of scientific discovery itself. He showed that the most profound insights often emerge not from laboratory experiments or technological breakthroughs, but from pure thought, from the patient application of mathematical reasoning to questions that push against the boundaries of human understanding. His work required no expensive equipment, no massive institutional support, no anything beyond pencil, paper, and a mind willing to follow equations wherever they might lead. The information paradox that haunted Stephen's later years remains unresolved, waiting for some future genius to provide the conceptual breakthrough that eluded even his extraordinary intuition. In a sense, this unfinished work is part of his gift to future generations, a mystery profound enough to inspire decades of investigation, a question deep enough to drive the next phase of theoretical physics. Stephen's incomplete work becomes a torch passed to younger minds, ensuring that his influence will continue propagating through human consciousness long after his physical presence has faded. The warnings he issued about artificial intelligence, climate change, and the need for space exploration take on additional urgency now that his voice has been silenced. These weren't casual opinions, but carefully considered judgments from someone who understood both the potential and the perils of technological advancement. His concerns about AI carried particular weight, coming from someone whose own consciousness operated in partnership with computer systems, who understood intimately both the liberating possibilities and the subtle dangers of human-machine cooperation. Stephen's advocacy for space exploration flowed from the same cosmic perspective that informed all his thinking. From the vantage point of someone who had studied stellar evolution and planetary formation, Earth's long-term vulnerability became starkly apparent. Our planet exists in a universe filled with phenomena, asteroid impacts, supernovae, gamma-ray bursts, that could end human civilization without warning. His argument for becoming a spacefaring species wasn't based on romantic notions of exploration, but on hard-headed assessment of existential risks. Yet for all his cosmic perspective, Stephen never lost touch with the immediate human concerns that give life its daily meaning. His delight in his children's achievements, his pleasure in winning scientific bets, his enjoyment of popular culture and social gatherings, these mundane joys coexisted seamlessly with his exploration of the universe's deepest mysteries. He demonstrated that it's possible to contemplate infinity while remaining grounded in the particular circumstances of a specific time and place. The zero-gravity flight of 2007 stands as perhaps the perfect symbol of Stephen's refusal to accept limitation as permanent. For those 25 seconds of weightlessness, the gravitational field that had imprisoned him for decades was neutralized, allowing him to experience the freedom that healthy bodies take for granted. The photographs from that flight show not just physical liberation, but something deeper. The joy that comes from proving that boundaries exist to be transcended, that limitations exist to inspire creative solutions. That flight also represented Stephen's connection to the space exploration he advocated so passionately. For a few moments, he experienced what astronauts know routinely, the weightless environment where humanity's future might unfold among the stars. His planned trip to space never materialized as his health declined, but the zero-gravity flight remained a tangible demonstration that even the most constrained existence contains possibilities for transcendence. The global response to Stephen's death revealed something remarkable about his place in human consciousness. The tributes came not just from fellow scientists or academic institutions, but from people in every walk of life who felt personally touched by his story. School children who had read his books, disability rights advocates inspired by his example, Ordinary people who found in his life proof that extraordinary things remain possible even in the most unlikely circumstances. The memorial services at Cambridge and Westminster Abbey became celebrations, not just of one extraordinary life, but of the human capacity to transform suffering into wisdom, limitation into liberation, personal struggle into universal insight. Stephen's ashes rest between those of Newton and Darwin, completing a trinity of minds that fundamentally altered human understanding of the natural world. Yet his influence extends beyond that rarefied company to touch anyone who has ever wondered about their place in the vast cosmos we inhabit. The books he wrote continue finding new readers with each generation, introducing young minds to the wonder of cosmological discovery. The foundation established in his name ensures that his commitment to making science accessible will survive the transition from his individual advocacy to institutional mission. The students he inspired continue their own research, pushing deeper into the mysteries he first illuminated. In all these ways, Stephen's influence continues to propagate like the gentle radiation that bears his name, invisible perhaps, but real and eternal. There's something profoundly moving about contemplating the trajectory of Stephen's life from the perspective of cosmic time. The universe he studied is roughly 13.5 billion years old, filled with structures and phenomena that operate on scales almost impossible for human consciousness to grasp. Against that vast backdrop, a single human lifetime seems negligible, a brief flicker in the cosmic darkness. Yet Stephen's story suggests something different about the relationship between individual consciousness and cosmic significance. In his 76 years, he managed to illuminate corners of reality that had been dark since the universe began. He revealed that black holes glow, that information might be indestructible, that the cosmos operates according to principles more beautiful and interconnected than anyone had imagined. A brief flicker, perhaps, but one that casts light across billions of years of cosmic evolution and will continue illuminating human understanding for generations to come. The disease that brought Stephen so close to death became instead the source of his most profound life. The silence that claimed his voice became the foundation for communication more clear and universal than speech. The darkness that should have consumed him became instead the wellspring of illumination that continues to guide humanity toward deeper understanding of its cosmic inheritance. As you prepare to drift toward sleep tonight, perhaps you'll carry with you this image of transformation, this demonstration that even the most perfect darkness can somehow, mysteriously, beautifully glow. Stephen Hawking's life stands as proof that consciousness, when allied with curiosity and courage, can transcend any limitation, overcome any obstacle, illuminate any darkness. The stars visible through your window tonight, if you're fortunate enough to see them past the glow of human civilization, carry light that has travelled for years or centuries to reach your eyes. That light began its journey long before you were born and will continue travelling long after your own story reaches its end. In a similar way, the insights Stephen generated during his extraordinary journey continue propagating through human consciousness, carrying illumination across the vast spaces between minds, connecting past discoveries to future possibilities. Sleep well, fellow travellers through space and time. Dream of universes where black holes sing with gentle radiation, where consciousness transcends every physical constraint, where love transforms limitation into liberation, and remember that somewhere in the quantum foam that underlies all reality, virtual particle pairs continue their eternal dance at the edge of event horizons, some falling into darkness, others escaping to carry light and information to the farthest reaches of space and time. The universe is a stranger and more wonderful place because Stephen Hawking lived within it for 76 remarkable years. His light continues shining in every mind that refuses to accept darkness as final, in every heart that finds hope in the most unlikely circumstances, in every consciousness that dares to ask the deepest questions about existence and meaning. Sweet dreams, and may your rest be filled with gentle radiation from the most luminous darkness ever discovered, the sleepy astronomer.